All right. Keep writing. 10.2, we're going to finish up today on special pairs of angles. Okay. I wanted to talk about real quickly what geometry is. Okay. Definition of geometry. Okay. It's a Greek word. Obviously, I can't pronounce the Greek. Okay. But the Greek word is mixed up of geo, which is earth, and metron, which is measurement. So earth measurement is basically what geometry is in English sense. Okay? It says it's a branch of mathematics concerned with the question of shape, size, relative position of figures, and the properties of space. Okay? A mathematician who works in the field of geometry is called a geometer. Okay? Now, the reason I want to say that is because of this. This is one of the main reasons we study geometry. Okay? Isaiah 40:12 says, "Who has measured the waters of the sea in the hollow of his hand, and marked off the heavens by the span or cubit, and calculated, contained, or comprehended the dust of the earth by the measure, and weighed the mountains in balance and the hills in the pair of scales." Okay? Basically, a lot of the things we just talked about in the definition of geometry is talked about in that verse, about measuring, weighing, the object of space, the waters of the sea. Okay? All of these two things are very, very much related. So it's very important that we understand geometry from a fact of every single thing on this earth is basically made up of some type of geometry. Okay? You think of a honeybee. Okay? You think of a hive of a honeybee. Okay? The hive of a honeybee is if you look at it, inside, every piece of the honeybee hive, where the honey is made, okay, is a symmetrical polygon. Okay? I mean, all the sides, they're equal to each other. Okay, it's the most perfect, can't remember the name of it, I've just slipped me just like that. I had it and then it slipped me. Okay, but a honeycomb is basically a perfect geometric figure. Okay, and unlike other people, I don't think that just happened by happenstance. You know, when that atom blew up in space, it just happened to make a honeybee that can make a perfect symmetrical polygon to build its hive on. Okay, it just happens, just happens to be that way. Okay, so the idea of space, the idea of position of figures, size of figures, shapes of figures, that was all what God had planned. Okay, is all the different shapes, all the different sizes, the relative weight of a feather as opposed to the relative weight of a boulder. Okay, all those things were considered. All of those things were done in His image and for us. Okay? For us to look at every single day. Okay? Now, let's talk about the other two things down here below it. First is parallel lines. Okay? Parallel lines. Write this down. Parallel lines. Parallel lines are the same distance apart from any 2 points. They do not intersect each other. Okay? The best example I can give you of parallel lines, because remember, we talked about the other day that lines continue on forever. They're infinite. Now, obviously, we can't draw a line in its infinity, okay, because then we would need an infinite number of paper, okay, and then you try to bring it, you can't keep up with one piece of paper, much less infinite number of pages of paper. Okay, so obviously when we think of lines, they always have endings. Okay, just like the 2 lines on the screen. We actually have 6, 10 lines on the screen. Just like this line here, it ends. There's an ending point to it. Okay, well, that line really continues on forever. If it continues on forever, we need to make sure that it's not going to intersect. Okay, so parallel lines, and the symbol for parallel lines is a little hard to read, so I'm going to write it out. Is that right there? Okay, and what I think of when I think of parallel lines is railroad tracks. Okay, when in the straight part of a railroad track, do railroad tracks run into each other? No, they don't run into each other. No. No. Listen to me. None of the tracks that a train is on intersect each other. Now, two different pairs of tracks can intersect each other, okay, but not the two tracks the train's on. Because if the two tracks the train's on ever intersected each other, that train's going to fall off and derail and wreck. Okay? So yes, they may intersect other pairs of parallel lines. Okay, in other words, I can have this right here. I can have parallel lines like this. Those are parallel, and then I have two other parallel lines that intersect them. Okay? But this could be a pair of parallel lines, and that could be a pair of parallel lines. Okay, obviously you have to have a pair of them for them to be parallel. Perpendicular. Okay, perpendicular are those lines right there. Perpendicular lines are lines that intersect. You need to write this down. Perpendicular lines, this will be on a test that you're going to have on Thursday. Okay, perpendicular lines are lines that intersect, forming four congruent angles. Perpendicular lines are two lines that intersect, forming four congruent angles. So we see here that the angle right there is our red box, which means what, Brandon? 90-degree angle. So, since those are perpendicular and they form four congruent angles, what does each angle have to be? Right angle, which is what measurement? 90 degrees. So, this has to be 90. Has to be 90, 90. All four of them have to be 90. Okay? Now, that brings us to our next example. These are corresponding angles. Okay? Corresponding angles. And here's how they are corresponding angles. We have upper right, lower right. Upper right, lower right. That's why those two angles are corresponding to each other. They share a corresponding spot on this intersected line. Okay? In other words, when I have two lines that intersect, I have a upper right, lower right, upper left, upper left, lower left. Okay? And so, if I have another line up here, I have the same thing here. I have four angles. There's an upper right, upper left, lower right, every time we intersect. So, these are corresponding angles right here. Okay? Now, if these two lines here are parallel, okay? These are parallel. These are not parallel. Now, why are these not parallel? Jesse, why are these two not parallel? Okay, let's look at it this way. Those 2 points right here. Is the distance between those 2 points and these 2 points the same? No, so they can't be parallel. The other reason they're not parallel is because if I continue this line out and I continue this line out, they're eventually going to intersect somewhere down here, right? So they can't be parallel. Remember, lines are infinite. Okay, lines are infinite in our thinking. Obviously, they're not there on that page. So, when the lines are parallel, these two lines, those two angles, are congruent. When the line is intersected, two parallel lines, okay, corresponding angles are congruent. Okay? All right, now, we talked yesterday about vertical angles, or we talked Friday about vertical angles up here. Okay, talked about these vertical angles. Vertical angles are congruent. Okay, we talked about adjacent angles. Okay, these are your adjacent angles. Adjacent angles aren't congruent. Okay, but they can, and they have to equal, a lot of times like that one's going to equal, those two adjacent angles are going to equal 90 degrees. Okay? So, Brandon. No, you can wait. All right, so I want you to turn to page 481. Everybody look at page 481. I want you and your group, on page 481, I want your group to do 2 through 6. Okay, you and your group do 2 through 6. All right. All right, I want you to do 2 through 6. All right, last thing I want to talk about. Been working good in the groups there. I want to look at this picture. I want us to look at this picture and look at the different angles that we have. Okay, obviously this picture of a house, maybe a barn. House looks like it's got a table and chairs out here in your screened-in area. Looks like that right there. And all right, now let's look at the different angles that we have involved here. Okay. First of all, these two lines here are parallel. Okay? So that means that these two angles here, 3 and 4, are corresponding angles. Okay? Now, here's what we've got to look at. If this is 117 degrees, what does 1 have to be? If that's 117 degrees, we have two angles there. We have a line that intersects another line, so the two angles have to equal what total? 180. So what is it, Tristan? What, 73? No, not 73. 63. So angle 1 is 63 degrees because we take 180 minus 117 degrees, and that would be 63. Okay? Now, we also know that these two angles right here, that's a straight line, right? So angle 3 and angle 4 have to be what angles? Since these are straight and this is straight, what's 3 and 4 got to be? They're corresponding, but what do they have to be? Is that perpendicular? Is this perpendicular right here? Yes. So it forms 4 congruent angles, which are what type of angles? No. I asked Brandon about it a while ago. Right, Christina? Right angles. So these are 90 degrees. So those two have to be 90 degrees. Okay? Now, this here is corresponding to angle 5. So what's angle 5 have to be then? The reason they're corresponding because you have two vertical angles right here that are parallel. So it has to be what? Yeah, it has to be 53 degrees. Okay, so what does 6 have to be? If 5 was 53, no. 6 has to be what? I'll give you a hint. 127. All right, so your homework. Your homework is, which we've done quite a bit of it, 10.2, 2 through 29. Okay? Once you put your desk back, you may go.